I'm Jim 5.0, and this is a connecting rod from one of Ford's newer engines, the 5.0 liter dual overhead cam TiVCT V8. The 5.0 liter TiVCT V8 is more commonly called the Coyote engine by the fans, and this is in reference to Ford Motor Company's project code name for while the engine was under development, and that code name, of course, is Project Coyote. The specific part number for this connecting rod is BR3Z-6200-A, and this is a Sinter-forged design which has more or less become standard in the industry of automotive connecting rod manufacturing throughout the world. Within the valley of the shank of this I-beam, you can see that there is a printing Ford Motor Company and a bunch of letters and numbers. If anybody understands what all this means, please do comment below and let me know. I am actually curious to find out what all that coding means for this connecting rod. This connecting rod is brand new and has never seen installation into an engine. The primary indication of that is that the end cap has not been fractured and broken off of the main portion of the connecting rod. As you can see, this machined line over here is a machine fracture line, so to help part the end cap from the other half of the connecting rod. And likewise, there is another end fracture line which is machined right here onto the other side of the inside of this crank journal. Another feature about this connecting rod are the 12-point end bolts. You need a metric 12mm 12-point socket to undo these bolts over here. At the top, as you can see here, it's been looks like it's been dipped in copper. I believe that is to help with the tight fitting of the bushing. The dimensions of this rod are as follows. For the crankside journal, which of course does not include the bearing, I'm using a plastic caliper over here. This is to prevent marring of the machine surfaces. I have measured this to be about 111 inches or 4.390 inches. And for the journal on the wrist pin side, the piston wrist pin side, of course with the bushing already in, I have measured that to be about 22 millimeters or 0.881 inches. According to online published sources of Ford Motor Company's connecting rod data, this connecting rod has a length of about 150.7 millimeters or 5.933 inches, which is very close to what I've measured. I measured 150.5 millimeters as the connecting rod length. The stroke of the engine that this connecting rod goes into is 92.7 millimeter or 3.649 inches, and so that gives a connecting rod rate to stroke ratio of 1.62 to 1. The Coyote connecting rod has the very same rod length as the connecting rods within the outgoing 4.6 liter engine. Whether this rod could actually be interchanged with the 4.6 liter connecting rods, I do not know. I have no idea if the critical dimensional factors are going to be exactly the same. Now for the width, or thickness I should say, of the connecting rod, which I measured right here with my calipers, the thickness I have come across is 24.3 millimeters or 0.970 inches, and that's also measured right here as well on the piston side. This is an I-beam construction, and the legs of the I are actually compact and pretty close in. This is a rather very light rod, and because of that, it does help reduce the rotating mass within the insides of the engine, which also helps the Coyote to accelerate more quickly and run very high RPMs. Currently, the Coyote engine and also its brother, the Roadrunner engine, have been pushed up to 7,500 RPM with no ill effect on this connecting rod. Of course, the Project Roadrunner engine uses an upgraded pressed powdered metal and a redesigned connecting rod for running at very, very high operating RPMs, probably as high as 7,750. The reason why these powdered metal connecting rods are considered sinter-forged or forged in some colloquial senses is because they do receive a die forging step. As indication of that, you can see on the inside of the valley of this connecting rod, of this I-beam, these tiny ridges. These ridges represent the material flow as the preform is being struck at forging temperatures within a fully enclosed die. And this is one of the end results. The forging step is absolutely necessary to make these connecting rods suitable for automotive use. Otherwise, they would just simply be too weak. The forging step, the die forging step, is actually to densify the material and thus giving it its exceptional strength. And in certain cases, depending on the material, has performed even more mechanically suitable than die forged connecting rods of older makes. And here is just this is a drop forge or rot forged crescent wrench. I'm just simply going to use this to indicate the density of the material. You could hear that. It gives a good steady ring to it. Whereas a cast piece or a piece that has not received the forging step would make a much more dulled thud rather than the nice ringing and pinging noise. The pinging noise indicates that this piece has a very good metal density to it. Well, I am Jim 5.0, and this concludes my review and explanation of Ford Motor Company's Coyote connecting rod.